Very good morning to all. ಎಲ್ಲರಿಗೂ ಶುಭ ಮುಂಜಾನೆ. Government of Karnataka, Department of Technical Education. I welcome for a second session on hydroelectric and thermal power plant. In this topic, today we will discuss on hydropower plant. Here, water is the primary requirement of hydropower plant. Hydropower is fueled by water, so it is clean fuel source. It means it won't pollute air like other power plant that burns the fossil fuels. Hydroelectric plant is a domestic source of energy, allow each state to produce their own energy without being reliant much on non-renewable energy sources. Hydropower is an inexpensive and environmental friendly form of energy. In contents, we'll see the introduction, later factors to be considered for site selection of hydropower plant, later classification of hydroelectric power plant based on the available head of water, based on the plant capacity, based on load and based on the construction. At last we will see on multiple choice questions. The first hydro hydropower scheme was developed in 1878 in England by William Armstrong. Later 19th century, in 1882, the world first hydropower plant began by James Francis developed water turbine in US. Later, in 1902, in India, the first power generation was started in Shivanasamudra around 4.5 megawatt. Introduction. A generating station which utilizes the potential of water at high level to produce the electrical energy is called hydroelectric power station. Hydro is a Greek word of water. Generation of electricity using the flow of water as the energy source. A dam is built across a large river to create a reservoir. You can see in a diagram reservoir. The water is stored in the reservoir as a potential energy. From the pressure channel through the penstock up to the turbine, the water will be flow. The flow of water gains the kinetic energy in a penstock. When it is fed to a turbine, here the kinetic energy is converted into the mechanical energy because the turbine blade will rotate. After that, when the turbine rotates, it connected to the generator shaft. That means the mechanical energy is converted into an electrical energy. Next, we see on the factors to be considered for the site selection of hydropower plant. First one, availability of water. Here, water is the main fuel of this plant. So, such plant should be located near to the river or canal or lake, etc., where the sufficient of water is available at all the time, so that the maximum and minimum quantity of water available throughout the year is also considered. Likewise, the available head of water in order to generate power it's necessary to have a large water at sufficient head should be available. Water head is directly related to the cost of generation of electric power. If the water head, that means effective head, is increased, water storage has to be reduced as well. A capital cost of the plant is reduced. Next point, cost and type of land. The type of land which is available should be rocky so that a huge dam is built over across the river so that the land should have a able to handle the stress which is developed by the construction of dam. When the water is collected at the dam reservoir, it will produce a gravitational force, so that the type of the land is also important. The cost of the land is also should be cheap so that the construction of dam will be easy. Next, storage of water. Water storage capacity, since there is a wide variation in rainfall during the year, therefore it is necessary to store the water for continuous generation of power. So storage of water in a suitable reservoir or a dam has to place by careful geological study of the area. If the water is stored in a sufficient head, can generate the power throughout a year. Next point is transportation facility. The transportation facility for the hydro plant through road or rail should be convenient so that if the new plant is to be established, the huge equipments to carry to work for a construction of dam should be easy. That means the roadways or railways with respect to the transport should be facility should be ease. Next point, distance from the load center. Power plant should be set up near the load center so that it will reduces the cost of maintenance of transmission line. If it is located away from the load center, more transmission line is required to supply the power. Next point, the site should have large catchment area. Next point, the site should preferably have high mountains on the two sides of the dam constructed. Next point, the land for the construction of plant should be available at low price. It relates with cost. The site selected should have less impact on ecology by the construction of dam. It means a huge amount of water which is stored in a dam will create a gravitational force, so that the site selection, that means the land or area selection, should be free from earthquake. The next point is the last point is very important, is the future extinction of the plant. These are the following factors to be considered for site selection. Next, classification of hydroelectric plant. First, based on the available head of water. What is the head of water means? As per height of water or water head, hydropower plant can be divided into three categories. In this diagram, we can see the hydraulic head, which is marked in red vertical mark. That means Hydraulic head is a value that measures the amount of mechanical energy available in water in a river or a dam. Hydraulic head is equivalent to the water level in static water body. That means measurement of height of the static column above an arbitrary point expressed in meters. The amount of energy produced depends on the difference between headwater level in the reservoir due to the upstream of dam and the tailwater level below the dam. In the reservoir, the water will be in the dam will have potential energy with a sufficient head from the intake through the penstock. The water is led to the turbine. It gains the kinetic energy because the flow of water will gain the kinetic energy. When it is passed through the turbine will rotate and it is the generator connected to the generator and the electricity is produced. When the water is passed through the turbine, from the tail race it is led to the river. First, low head power plant. The plant have head less than 30 meters is called low head hydropower plant. Next one, medium head power plant. The plant in which the water head lies between 30 meter to 300 meter is called medium head hydropower plant. Next is high head hydropower plant. The head which is available is more than 300 meters, then it is called high head hydropower plant. Next, we look on to low head hydroelectric power plant. The above figure shows the low head hydroelectric power plant. That means it should be below 30 meters head. To create a low head, a dam construction is very essential in these types of plants. Water resource level, that is river or pond, is placed just behind the dam to create a necessary water head level. Water is led to the turbine through the penstock. This type of hydro plant is located just below the dam and it creates a useful water level as well. And here no such tanks is required for this type of plant. Dam itself discharges the surplus water from the river. Since head is low, huge amount of water is required for the desired output. That's why in these plants, a large diameter of pipe with low length, large diameter of pipe with low length is used for this plant. In such type of plants, uses low speed and large diameter type generator because the water head height in a dam is less because less than 30 meters. That's why a huge pipes are used in a penstock. The production will be less, say around 30, 40 to 50 megawatt in this low head power plants. Here, the Francis turbine, Kaplan turbine or propeller turbine is used in this type of low head hydropower plants. Next, we look on to medium head hydroelectric power plant. In this medium head, you can see there is a open channel, that is water from main reservoir is taken through a forebay. Here the forebay will act as a dam. From the forebay, Through the penstock, it is directly fed water to the turbine. In this power plant, the river water is usually tapped off to the forebay on the bank of the river. From the forebay, the water is led to the turbine through the penstock. The forebay is provided at the beginning of the penstock, serve as a water reservoir for this type of plants. A forebay is used for medium head hydroelectric power plants. It works as a surge tank. The forebay is tapped with the river and the water is led to the turbine via penstock. This plant uses either Kaplan or Francis turbine. Next classification, high head hydroelectric power plant. That means high head means it is more than 300 meters. The dam is constructed across a river or lake and the water from the catchment area collects at the back of the dam to form a reservoir. Here the catchment area means it is a backside area of the dam where the hilly regions are covered. That means the water flow stream in a river backside to the dam is considered as the catchment area. A pressure tunnel is taken off from the reservoir and the water is brought to the valve house at the start of the penstock. Here you can see the valve house in a diagram. The valve house contain mainly sluice valves and automatic isolating valves. The work of this valve is very important. The former, which controls the water flow to the powerhouse, and the later cuts off the supply of the water when there is a chances of penstock bursts. From the valve house, water is taken to the turbine through a huge steel pipe known as penstock. It has been indicated in a diagram. From the valve house to the powerhouse, through the penstock, the water will be led. In a powerhouse, the water turbine converts hydraulic energy into the mechanical energy. The turbine drives the alternator which converts mechanical energy to electrical energy. You can observe in this diagram there is a surge tank. Surge tank is open from the top. It is built just before the valve house to protect the penstock from bursting in case of turbine gates suddenly closed. The turbine gates are suddenly closed due to the electrical loading being thrown off. If the load on the generator is reduced, that means the water flow through the penstock to the turbine is stopped or reduced. The huge amount of water through the penstock which is falling from a minimum head will have a high kinetic energy from top to bottom. When the sudden water is stopped in a penstock, the water will move back in a penstock in reverse direction. That means from powerhouse back to the surge tank. The surge tank observed this pressure swing by increasing the water level which is throwback from the turbine house. At this instant, after a duration, if the plant start continuing the electrical energy production, Once again, the water is once again fed to the turbine. Here the surge tank is very important, and it will play a very important role that will absorbs this pressure swing in this plant. Next, we will see the classification of hydroelectric plants. Second type is based on the nature plant capacity. First one, very low capacity plants up to zero point 0.1 megawatt. Next, low capacity plants which is from zero point 0.1 megawatt to 1 megawatt. Third one is medium capacity plants, that is 1 megawatt to 10 megawatt. High capacity plants, that is above 10 megawatt of generation capacity. If we see the classification based on plant capacity, it can be understood easily by one is micro hydro plant, mini hydro plant, small hydro plant, medium hydro plant, large hydro plant. First we will see a large hydro plant. If the generation capacity exceeds 100 megawatt, it is considered as large hydro plants. And usually these type of plants feed directly into a large grid. Medium hydro plants ranges from 15 to 100 megawatt. It is also usually into the grid directly. Small hydro plants, the generation capacity is 1 to 15 megawatt. These also uses to feed the electricity is generated directly to the grid connected systems. Then mini hydro. See, mini hydro will be ranges from 100 kilowatt to 1 megawatt. Either they are isolated or feeding into a grid. In recent times, mini hydro has gained very more importance because the development of small hydro for rural areas is very challenging. Some factors like environmental, social, technical, and economical issues are more. There, you can set up a small hydro with sustainable generation of small hydro plant so that it can meet the rural electricity goals. By establishing mini hydro plants in very rural areas, remote areas, so that the electricity can be supplied for rural peoples. It is followed in many countries. So more than 150 countries are using hydroelectric power plants to generate the power. And we can say the mini hydro plant, it is reliable and economic source of electricity in remote areas. Next is micro hydro plants. These micro hydro plants ranges from 5 kilowatt to 100 kilowatt. Usually it provides power for a small community or rural industry in remote areas away from the grid. Remote areas where there is no roadway, railway approach, a transportation facility is, it cannot directly connect with in a convenient way. The area is called remote area. For the remote areas, if we want to give a power, we have to run a transmission lines, say in a forest. or in a hilly areas. It is highly difficult because the investment on the transmission line towers will be huge, considered as a economical problems. For this type, mini hydro, micro hydro, and pico hydro plants will be installed. At last, pico hydro, you can say the few hundred watts of power generation, that is up to 5 kilowatt. Pico hydro for a remote communities. This mini hydro, micro hydro, and pico hydro, it is very important because millions of people in remote areas had a lack of accessibility of electricity till now in many countries. In our own country, still many peoples cannot access the electricity which they are located in remote areas. What it happens, it creates a large imbalance in development of potential between urban and rural areas. This mini, micro and pico hydro plants offers very low cost effective way of accessing the electricity. Next type of classification of hydro power plant, it is a third type of classification based on loads. Based on load is first one is peak load, that means base load plants. Second one is peak load plants. The base load plants, this is the large capacity of power plant. This plant work as a base portion of load curve of a power system. You can see in a diagram that is a base load which will surge in a load curve called as base load plants. Base load plants is suitable for constant load. The load factor of this plant is high and it is performed as a base load. Here, the runoff river plants without pondage and reservoir plants are used as a base load plants. Most of the plants which are reservoir based plants, so that the water is stored with sufficient head and it can be used as a continuous generation as a base load plants. Next is peak load plants. This plant is suitable for peak load curves of the system where demand is high. This type of plants does their job as well. Runoff river plants with pondage can be employed as a peak load plants. If the water supply is available, it generates large portion of load at a peak load period. It need huge storage area. And the reservoir plants also can be used as a peak load plants. This type of plants can serve power throughout the year. If you observe this diagram, x-axis will be time scale and y-axis will be the power generation. If you want to understand a base load and a peak load in a household, base load means the load which consumes the electric power throughout a day, 24 bar 7. In household, you can compare fridge and few electric bulbs, usually which are located in a different location in a house, which runs continuously throughout a day, is called base load. That means the load is continuous. Peak load means if the family members are 4 or 5 in example, the load demand will be varies from hour to hour. Say from 5 a.m. to 10 a.m., the requirement of the electricity will be very high. Like in evening, after 5 p.m. to 10 p.m., the requirement of the electric power will be high. These are called as peak loads. Classification of hydro plants based on load. Third one is pumped storage plant. This pumped storage plant is very important because these plants operated at peak loads. If you see the diagram, it is having the reservoir, from the reservoir to the turbine with a sufficient head. Through the pipes, the water is fed. When it is passed through the turbine, the electricity is generated and it is collected at the bottom of reservoir. When the water is pumped up to the top reservoir at night, where the demand of the power across the country is low, sudden demand of power is demanded. The headgates are opened and the water rushes down to the tunnels to drive the turbines, which drives the powerful generator, so that the power can be generated at very instantly. When the demand required, it can start generating the power. The water then collects in the bottom reservoir ready to pump back later. You can see in a diagram the arrow mark on the penstock. When there is a high demand, the gates are opened and the water is rushed to the turbines, the power will be start generating. When there is a low demand, that means they will prefer night because across the country the power requirement during the night time, say from 11 p.m. to 5 a.m. or 6 a.m., the power consumption demand is very low. Next, classification of hydro plant based on the construction. Based on the construction, according to the extent of water flow regulation, hydroelectric plants are classified in three categories. One is runoff river plants without pondage, runoff river plants with pondage, and reservoir plants. Based on the construction, first one is runoff river plants without pondage. As the name specifies, without pondage means without storing the water. In this diagram, you can see a dam, a sluice gate, canal, forebay, powerhouse, tail race. The dam is constructed in such a way that a part of the water flowing through a river, which is flow through a forebay, through a canal, and the power is generated. Once again, the water is left to the river. These plants are located such that they use water as it comes without any pondage or storage. During the low flow periods, the generation capacity of the plant will be very low because the generation of power in hydro plants mainly depends on water head and water flow. During the period of high flow, these plants can supply sufficient portion of base load. If the water flow is high, the production of the electricity will be high in this type of plants. Next, runoff river plants with pondage. These plants uses pondage which stores the water during off-peak periods and use this water during peak periods. Plant can take care of hour-to-hour fluctuation in load on the station. Thus, pondage increases the generating capacity of the station. Next, reservoir plants. These plants store water in big reservoir behind the dam. Water storage in the reservoir increases the generating capacity of the plant, and most of the plants belongs to this type of category where the water is stored in a reservoir through the tunnel, through the surge chamber, from the valve to the powerhouse through the penstocks. The water is fed to the turbine and the power is generated. This is the unique design of peak load plants. Here, two types of water pond are used. You can observe. In this plant, it is designed to peak load plants. Here, two types of water ponds are used called upper head water pond and tail water pond. Two water ponds are connected each other by a penstock. Main generating plant is lower end. During the half load periods, surplus of energy of this plant is utilized to pump the low head pond to the upper head pond water. This extra water used to generate energy at peak load periods. By doing this arrangement, same water is used again and again. Extra water is required only to take care of evaporation and seepage. Next, we will see the multiple choice questions. First question. Potential energy of water is used to drive the turbine. True or false? Answer is false. Because when the water falls from the dam to the turbine, the potential energy of water is converted into the electrical energy. This kinetic energy is used to drive the turbine. Second question. Hydroelectric power plant is mainly located in dash. Options are flat area, desert area, hilly area, deltas. Answer is hilly areas, because in order to get sufficient height, hydro plants are constructed in hilly areas. In desert and flat areas, sufficient of water head cannot be maintained, and deltas are not suitable for this because of high sedimentation. Next question. Which of the following is not a requirement for the site selection of hydro plant? First option, availability of water. Second option, large catchment area. Third one, rocky land. Fourth one, sedimentation. You have to look the question carefully, which is a not requirement of site selection. Answer is sedimentation. Options A, B, C are the requirements for the site selection. D is the answer because this sedimentation may reduce the water storage capacity of the reservoir and may also cause damage to the turbine blades. Availability of water, large catchment area, rocky land are the primary requirement for site selection of hydro plant. Next question. The amount of electrical energy that can be generated by a hydroelectric power plant depends on dash. Options are head of water, quantity of water, specific height of water, efficiency of alternator. Answer is quantity of water because the quantity of water, the potential energy of large quantity of stored water is used in hydro plants to generate electrical energy. Head of the water is important to get kinetic energy from the potential energy. And the efficiency of the alternator represents what percentage of input mechanical power it can to convert the electrical power. So the quantity of energy is the answer. Next question, hydroelectric power plants is dash. Answer is conventional source of energy. Conventional source means the energies which are used very long time. From the long time, these energies are using. Next question is, what type of hydro plant is it if the plant head is above 300 meters? Answer is high head power plant because low head power plant, the plant head height is ranges up to 30 meters. Medium head hydro plant means 30 to 300 meters. High head hydro plant means above 300 meters. Answer is high head hydro plant. Next question. Which plants supplies the peak load for the base power plants? Answer is pumped storage power plants. Because in previous slides we have seen the pumped storage plant, it consists of two ponds. One is during the power generation from off peak period, the water is again feed to the top pond so that during the peak loads the power can be generated. Next question. Which type of hydro power plant can be with or without pondage? Answer is run-off river power plants. Because run-off river power plants does not require pondage. Next question. The location of surge tank is closed to. Options are tail race, dam, turbine gate, spillway. Answer is turbine gate. The purpose of surge tank is to serve Why the surge tank is very important? Because when the water hammering will be takes place in the penstocks. That means from the valve gate to the turbine, the water is fed to the penstock. When the load is removed or reduced in a plant, the water flow to the turbine is stopped immediately. When it is stopped suddenly, the water is moved back to the penstock in upward direction. The huge pressure will be created. The surge tank is an open well so that the sudden reversal of water from the turbine through the surge tank, the air gap will be reduced. If the surge tank is not provided in high-end plants, there is a chances of bursting of penstock pipes due to the water hammering. Next question is, which type of hydro plants if the head of the hydro plant is 30 to 100 meters? Answer is medium head hydro plants because low head is less than 330 meters and high head is more than 300 meters. Here are the answers for the above discussed MCQs. These are the references. Thank you.